Hi guys, welcome to my digital maths masterclass on IIT JEE. I'm starting this series for my Indian students so that they can prepare or they can be helped with some questions to prepare for their IIT JEE exam, entrance exam. That's an engineering entrance exam for Indian students. And this series would contain uh, advanced and mains questions on various topics from the JEE series, questions that has been asked or questions on similar topics that are likely to be asked in the exams. So let's begin with our questions. Uh, let's begin with this question. Okay, if you can read this question out. The first question is from IIT JEE mains. If the questions x square plus ax plus b equals 0 and x square plus bx plus a equals 0 share a common root, evaluate the expression value of a plus b. So how are we going to approach this question? Simple, they're asking the value of a plus b. It has been said that they share a common root. What does it mean? Simply means I can subtract the equation and find the common root. If I subtract these equations, what happens? Hey, if I subtract both the equation, what's going to happen? It's ax minus bx plus b minus a equals 0, which gives us x a minus b is equals to a minus b. And a is not equals to b. Since this is given, we can say x is equals to 1. So this is the common root which they're talking about. Now what they're saying, if the equations share a common root, we know the common root. Now if you plug in this value back into either of the equation, what you will get, let's say the first equation, 1 square plus 1 into a plus b is equals to 0, which simply gives us a plus b is equals to minus 1. Plug in x is equals to in another equation, you will get same answer, a plus b is equals to minus 1. So a plus b is minus 1. The answer is minus 1 for this question. Let's go to another question, which is from IIT JEE Advanced. Okay, now if I look over here, what's happening? Find all the valid real values of parameter a for which the equation has exactly three distinct real roots. Now here we can do two things. Either I can simply solve it algebraically, or we can use a graphical solution, right? So I prefer you go with the graphical solution. The equation, look at the equation very carefully. The equation is x square minus 4x plus 3 equals 8. Let's see that. X square minus 4x plus 3. Okay, so this is the equation. X square minus 4x plus 3 equals to a, and this equation has a mod. Now if I just focus on this particular thing, I have to find this these two. What does these two equation means graphically? It means y is equals to a and y is equals to mod of x square minus 4x plus 3, intersection point of these two graphs. So now they are saying the condition or the value of a for which these two graphs will intersect at exactly 3 points, right? So first I'll draw the graph for x square minus 4x plus 3. How will I do that? I'll factorize this thing. So if I factorize x square minus 4x minus 3 plus 3, this is what I am going to get, which gives us x minus 1 and x minus 3 equals 0. So x is equals to 1 and 3 are the roots of this equation. So if I ask you now, what should be the shape of this curve? Let's say this is the Cartesian plane. So the shape of this curve has to be, this is 1 and this is 3, let's say. So this is the likely shape of this curve, right? So if this is the shape of this parabola, what's happening? The parabola is intersecting the x-axis at 1 and 3, means 1 and 3 are the roots. So what has to be the midpoint of this, the vertex of this graph? It has to be the midpoint, the abscissa has to be the midpoint of these two, 1 plus 3 by 4, 2, which is 2, comma, 2 square minus 4 into 2, 8 plus 3, which is 4 plus 3, 7 minus 8 is minus 1. 2 comma minus 1 is the vertex coordinate of this parabola. Now this is the graph for x square minus 4x plus 3. What is the graph of mod of this thing? The graph for mod of this curve is this green curve. When you apply a mod, things all the negatives become positive. So this is the likely graph for mod of x square minus 4x plus 3. So now how will this flip? This will just be a mirror image. This curve, upper curve, green curve will be just a mirror image of this lower red curve. So what will be this point? This will be 2 comma plus 1. Now let's get to the question. The question was, if these two curves has exactly three solutions. Now let's go and play around the values of a. Let's say the value of a is, okay, yes, let's say if a was greater than 1, here, somewhere here, if you look at over here, there are 2 points at which this horizontal line is intersecting the parabola, which means here this equation has two roots if a is greater than 1. Next, if this is the condition, means a is equals to 1, what's happening? A is just tangent to this point, right? And A is intersecting it at two other points. So overall 3 points are there. So this is the condition we were looking for. A is equals to 1. Okay, what if A lies between 0 and 1? You can have a look at it over here. It intersects this curve at exactly 4 points. So there will be 4 roots. So the number of roots this equation have depends on the value of A. A greater than 1, 2 roots are there. A is equals to 1, 3 roots are there, and A less than 1, A between 0 and 1, 4 roots are there. And what if A is equals to 0? Again, 2 roots are there, which are exactly the roots of this quadratic equation 1 and 3. If A is less than 0, no roots are there. Got it? So this is how simple it is when you just know how to draw a graph with this equation. I explained it, it took almost 5 minutes. So once you start doing it, you'll be able to do it it should take you not more than 2 minutes once you know how to draw this graph. Got it? 1.5 to 2 minutes is more than enough for this question. So this is how we'll be continuing our sessions with 2 questions per session, one from mains and one from the advanced. So thank you for attending the session. If you want a personalized course for preparation in IIT JEE or your grade curriculum from 8 to 12 or a foundational program, you are welcome. You can contact me through my mail ID or my phone. Thank you. Bye-bye.